All right, we're back. Let's take a look at our last little adjustment here. We're talking carbon chains, and before we were dealing with alkanes, which means it's single bonds everywhere, all surrounded by hydrogens. Another class of compounds is a slight adjustment. They're called the alkenes. Okay? E-N-E means there's a double bond somewhere. So I want you to write down double bond. Okay. Now, let's take, for example, butene. Bute means there are 4 carbons, so I'm going to draw 4 carbons. And then E-N-E, that ending means there's a double bond somewhere. So let's put a double bond in the middle, just so it's nice and symmetrical for you to look at. Okay, now let's add in some hydrogens, but remember, every carbon has a maximum of 4 different bonds. You can only have 4 bonds total. So I'm going to put in 1, 2, 3 in all the empty spaces here, hydrogens. Over here, this one has 1, 2, 3 bonds already, so I'm putting in a single hydrogen. Doesn't matter whether it's going up or down. This one is 1, 2, 3, so I'll put in the hydrogen there. That's 4 total. And then I've got 1, 2, 3 more spaces here. So because of that double bond, there's less hydrogens I can put in because the electrons have been used for bonding, for sharing. So let's count this up. This is C4, 1, 2, 3, 4, 5, 6, 7, 8. C4H8. There's the formula for butene, which is slightly different than butane. Now, the other slight adjustment we have to make is YNE. Let's use black here. YNE tells us there's a triple bond. Okay, the prefixes are all still the same meaning. So hexine, hex means 6. 1, 2, 3, 4, 5, 6. 6 carbons. YNE means I've got ine as the ending. That's a triple bond. 1, 2, 3. Put in a triple bond somewhere. And now we have to add in hydrogens. 1, 2, 3, 4, 5. Now this one, 1, 2, 3, 4. It's only got 4. It's got 4 bonds on already. It doesn't have any space for hydrogens. So we just leave that one alone. It's just carbon. Same over here. 1, 2, 3, 4. There's nowhere to put an extra hydrogen. Over here, we've got room for 2 more. And over here, we've got room for 3 more. Now you notice, I put in those dashes, those bonds. I could put hydrogens on each one, but chemists get tired of that. They're like, you know what? We know there's hydrogens here. We're talking to other chemists with this. So why write in a hydrogen when everybody knows it exists there? So what they start doing is just eliminate. The hydrogens are there. They just know it. They just don't write it. So anytime you see a bond with nothing attached to it, we're assuming there's a hydrogen there. We just don't put it. This is one of their shortcuts. So they're just going to say, you know what? We're going to assume that every bond goes to a hydrogen, unless we show something else. So if it was an oxygen, they would actually put in oxygen. Otherwise, they're all hydrogens. Just another shortcut so you don't have to write as much. This would be hexane. Now we've got one last little adjustment we're going to make, and that's where the bond goes. So I want you to look at these examples. They're in your notes. And this can be kind of confusing at first. You kind of have to change the way you think. All right, this molecule, we would count carbons, and it's 1, 2, 3, 4, 5. So penta is our prefix. And then I look to see what's going on. Is it pentane, pentene, or pentyne? Well, I see a double bond. So that means we have E-N-E that tells us we have a double bond. There's trouble though. This one down here is the same thing. 1, 2, 3, 4, 5. This is pent. It has a double bond, E-N-E. There's got to be a way to signify the difference. This has a double bond in the middle. This one's got a double bond in the end. And they actually behave slightly different depending on what they're interacting with. So chemists have used a system where they take a number, and the number tells you the location. And how do we tell a location? They number this based on the carbons. 1, 2, 3, 4, 5. And they'll use the smallest number possible to signify what's going on. This one, we have the double bond on the second carbon. I know it's on the third also, but they're using the smaller number. So they would call this 2-pentene. This one down here, 1, 2, 3, 4, 5. They're going to call this 1-pentene. So that number just says the location, and the ending tells us it's the location of what? In this case, the double bond. Now, this is going to be a little tough to get used to, but those are the only forms of pentene that exist. There is no 3-pentene or 4-pentene. And here's why. 1-pentene is a 3-dimensional molecule. So let's imagine that it's this ruler here, and we've got the double bond on this end. Well, this thing is always moving around, okay? It's not just sitting on a piece of paper. So if that were to accidentally get flipped over upside down, it's still one pentene, but now it's upside down, and the bond is over here, not on this side. So what they do is they count from the end that is closest. So if the double bond is over on the left, they'll count carbons from the left. If this whole thing flips over, and the bond is over here on this side, then they'll count 1, 2, 3, 4, 5 from that end. You go closest to the special thing you're trying to signify. Okay. So this one over here, 2 pentene, if I were to flip it over, it's still 2 pentene, but now the double bond ends up here. So it's really, there's no such thing as 3 pentene, because it's still just 2 pentene, it's only upside down, or flipped around. So just, we have to get used to the fact that this is a flat model of a 3-dimensional structure that can move. All right? So you're going to look at these and sometimes go, hey, there's 10 different options. There really isn't, because every molecule can be flipped over, twisted around. It doesn't have to be sitting the way that it's sitting. Okay, so we're going to have to get used to that. Last thing we'll take a look at is one practice thing. Okay, I want you to look at this molecule. It's zigzagging all over the place. Don't worry about that. Count the carbons. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I have octo. Okay. Now, I look at this and go, hey, there's a double bond, so it's octene instead of octane. And now I have to say where that double bond is. Instead of counting from this side, let's count from this side since it's closer to that spot. 1, 2, 3, so this would be the second carbon. This would be 2 octene, which would be the same if I flipped it over and it was over on that side. Okay? You're going to use your assignment you're going to get to try to draw some of these basic structures and just get used to the fundamentals so that we move on. You have this down. It's something that you don't have to think a lot about. It just becomes habit. Okay? And there'll also be another video to help you through some of your lab calculations. All right, guys. Be productive. Have a good day.